Welcome back. Today, we're diving into the heart of electrical interaction, Coulomb's law. Why does the force between charges get so much weaker as they move apart? It's all about geometry. This is Coulomb's law. That r squared at the bottom is the secret to the inverse square rule. The force is directly proportional to the amount of charge. More charge, more push or pull. But that distance factor is where it gets interesting. Imagine the force spreading out from a point. As you move further away, that same force has to cover the surface of an ever-growing sphere. Since the surface area of a sphere depends on the square of the radius, the intensity drops by that same square. This isn't just for electricity. Newton's law of gravity follows the exact same inverse square logic. Light, sound, and even radiation, if it spreads from a point in 3D space, it's inverse square. The K constant is huge, about 9 billion, making electricity far stronger than gravity at short distances. Double the distance and the force doesn't just halve, it drops to 1/4. Triple the distance and it's down to 1/9. It falls off fast. Remember, force is a vector. It always acts along the straight line connecting the two charges. Like charges repel. They want to get as far from each other as possible. Opposite charges attract. This simple rule builds everything from atoms to molecules. Inside an atom, Coulomb's law is the glue holding the electrons to the nucleus. Without the inverse square law, atoms would either fly apart or collapse instantly. On our scale, we see it in static electricity, like a balloon sticking to a wall. What if there are many charges? We just add the individual forces together. That's superposition. The net force is the vector sum of every single interaction happening at once. If we lived in a 2D world, it would be an inverse linear law, but we live in 3D. In a way, the inverse square law is proof that our universe has 3 spatial dimensions. Field line density is just a visual way to represent the inverse square drop-off. At very small distances, the force becomes unimaginably strong. This is what prevents you from falling through your chair. So, remember, like repels, opposites attract, and geometry dictates the strength. Inverse square is the universal language of spreading influence. It's everywhere. Next time, we'll see what happens when we talk about the energy behind these forces, electric potential. Thanks for joining me. Keep questioning, and I'll see you in the next micro lesson.